Hey guys, so in this video I will be showing you how you can interact with the blockchain from your web app, whether that's using React, Vue, Angular, or whatever other library framework you're using, but definitely React. So let's get into it right now.
What I have here is a very basic Create React app, and the first thing that we're going to do is actually go ahead and install a library called Web3. So just go ahead and type npm install Web3.
So what Web3 does is it's essentially a collection of libraries that make it easier to just do blockchain stuff.
For example, you can use it to check if a given string is a valid Ethereum address, or maybe sign a message with a private key.
And it also makes interacting with contracts a lot easier.
It will take care of encoding, decoding all different calls and transactions for you. And just to clarify, I will be mainly referring to Ethereum, but this whole thing actually applies to
layer 2 solutions and side chains like Binance Smart Chain. And by the end of this video, there's no reason why you shouldn't be able to go to A16Z and raise $200 million in Bitcoin funding for your revolutionary DeFi startup. So let's get into it.
So let's go ahead and into our just app component for now, and put down a use effect just to start off. And now let's begin with the Web3. So we have const Web3 and new Web3. And here you will be passing your provider URL. And this is a link to your Ethereum node. This node is basically your gateway to the rest of the network. But don't worry, you won't need to actually set up your own node and host it on something like AWS or anything. Luckily, there's many services like Infura that already do all that for you. And all you'll be needing is a link from them. So you just paste the link here and you're ready to go. So we have const provider URL, and you'd typically be storing this as an environment variable. So you can do provider URL. Also in this video, I will be showing you two different scenarios that you may be facing. So let me show you the first one to begin with. So in this case, you will have your own smart contracts that you will deploy using Truffle or something, which is what I'm using. So here we have a very simple NFT contract that will be deployed to the local Ganache instance, which is a local blockchain that you can use for testing purposes. So we'll be going here and npx Ganache CLI, and that's it. Now we have a local blockchain running on our device. So let's deploy the contract first. So what we'll do is npx truffle migrate. What Truffle will now do is we'll compile the contracts and create this JSON file inside the build/contracts directory. This JSON file now contains a lot of information. Most of it you won't be using, but this file also contains the address your contract was deployed to, along with the ABI, which is something I'll get to very soon. So now we've deployed the contract. As we can see, we have this build JSON file, so we can go back to our app. So we have the provider URL, but if we're going to be only testing locally, we can add a string like localhost 8545. This is the port that Ganache will be running at. Okay, so now we have our provider setup and provider URL. Perfect. Okay, so now the thing with decentralized applications is that your users will need a wallet to actually sign the transactions and other stuff. And the most popular out of all these wallets is, of course, MetaMask, which if your users are quite familiar with crypto and the blockchain space, they will probably already have it installed as a Chrome extension. But if your users are not very familiar with crypto and blockchain stuff, you can use many services like Fortmatic. What they do is they will give your users a wallet without having anything installed. In this video, I will only be showing you how to integrate MetaMask, but once you have learned that, the steps for other wallets should also be quite similar. So what MetaMask does is it injects itself into the browser. So when you make any transactions or calls, you will be dealing with MetaMask itself and not with your provider. And by the way, MetaMask itself uses Infura in the background. but you will never be interacting directly with them. You'll be dealing with MetaMask or whatever other wallet service you're using. So how do we go on about integrating MetaMask? First, we will check if MetaMask is actually installed. So window.ethereum. As I said, MetaMask injects itself into the browser, so you will be able to access it through the window object. So if type of provider is not undefined, so the provider has been injected, that means MetaMask is installed. The next step is to ask the user to connect their wallet to the website. And the way we do that is we will send this request to the provider to get access to the accounts of that user. And then because this is a promise, we wait for the response. For now, we'll just log the accounts. Also, let's just catch the error. Console log, very simple for now. Okay, so save, and now let's run this. Okay, so if we go to our web app now, host 3000, now we will be prompted with this MetaMask connection dialog. So we will select the account that we want to use, press next, connect, and there we go. So if we check the console now, there will be an array, and this is the account. It won't show all the accounts, only the one that's connected and selected. So we want to go back to our code and take the provider and pass it to our Web3 instance. Now we can use our Web3 instance to make calls, transactions, and cool stuff like that. Also, we can get rid of this URL now because MetaMask will be handling everything for us. In fact, even the network selection will be done right here. Right now we're on mainnet, but we can go to localhost because that's what we will be using for today. Okay, so here's something else we can do now. We can listen to MetaMask account changes. So if we add this event listener, console log accounts, save. So MetaMask, if I change my account now to this, I'm going to connect it first. And yeah, so as you can see, there's another output in the console. This is the other account. So every time I change it, there's a new output. So with just these few lines of code, we've already linked MetaMask, and we can now start interacting with the smart contracts. But first we will need to do some tidying up because this code isn't very reusable and it doesn't look good. So web3 client.js, I'll create this new file. You can name it whatever you want. So here we can go export const init, and we can take this code from our app component and paste it here. Let's declare this new variable, let selected account. Okay, so every time we select a account, we assign it to this variable. Selected account is selected account. And now we can do the same thing, just a lot better. So Web3, and in here we'll do this. Save Web3 is not defined, of course. Import Web3 from Web3. There we go. Save. Yeah. Let's check. Selected account is this. Now account 3. Change to changed again. Yeah. Okay, so now it's time to actually define the contracts. Okay, so this is the first scenario. We will use the contract that I showed you guys earlier. So new web3.ath contract, and in here we will be using the file inside here, the JSON file. And to do that, we will be importing that NFT contract build, whatever you want to call it, from truffle build contracts nft.json. Okay, so we have this contract, we do that, and then ABI. The ABI part is what we're interested in. And also the second parameter is the address of the contract. We can also get that from the same file, but first we will need to get the network ID for the current network. So await a Web3 ETH net. Yes. Once we have the network ID, we can use NFT contract.networks. I think that's what it is. Net ID, network ID, and address. That should give us the address. And of course, we will need to make this function async. Okay, so we get this error message. It says you attempted to import this, which falls outside of the project src directory. And if you use create React app to create the application, then what you will need to do is go into your dependencies for React and add a new dependency. You can call it something like contracts, and then we'll do file truffle build contracts. Truffle build contracts. Now let's exit the application, npm install. Okay, and now in here we can just do contracts, which is the name we defined here. We can just treat it as another dependency. So contracts and then just nft.json. Let's save this, npm start. Okay, so now that issue has been resolved. That was quite simple. By the way, you don't need to do it this way. You could simply copy the file from build and paste it in the src directory and access it that way. But if you do it that way, every time you deploy the contract locally or to a network, you will need to copy it each time, copy and paste it each time, because your copied file won't contain the latest address and deployment details. Okay, so now we have this, and what was the error message again? Cannot access NFT contract before initialization. Here we need NFT contract build. Yeah, so that's all set. Now we can do different things with the NFT contract, but let's declare it here instead, NFT contract, and then assign it here, because we'll create another function. With this contract, all we're going to do is just mint a new token. This is just for showing you guys. So we'll do mint token. We'll take the NFT contract dot methods. So once you have the contract to access methods, you do methods and then dot, and then this will be the actual function that you have in your contract. In this case, it's just the function mint, and it takes one parameter, which is the owner. We go back here, methods dot mint, and here we can add the selected account that we have over here, which we get from MetaMask. Now we have that selected account, and then we do send. And now here we'll also specify the from. This is the account that will be actually sending the transaction. By the way, these can be different. This is just the account that sends the transaction, and this is the account that will be owning the minted token in this case. So we will return this. And yeah, now let's go back into our app component. Let's do some more stuff. So const minted set minted. This will just be a Boolean value. Use state false. If it's not minted, we will have a button that says mint token, and on click we will mint. However, if it's already minted, then we'll display a simple message like token minted successfully. Okay, so we import mint token from our Web3 client file, and we create a new function called mint over here. This will call mint token dot, and then because this is a promise, we will also add a then tx. This will return the transaction details and then catch for any errors. Mint token console log the transaction, and we will also set minted to true. Yeah, so let's go back to our application, and now we have mint token, and let's try pressing it.
Get off
We will need to first initialize. We didn't initialize the actual contract. We just went straight to mint token. So first we check if, let's create a variable over here, let is initialized equals false, and once we have it be initialized, we'll set it initialized equals true. And also if there's an error over here, we'll just return it. So if it's not initialized, we will await the initialization of it. And let's make this async. Going back to the browser, let's try again. Mint token. There we go. So now MetaMask pops up with the asks us to actually approve the transaction and send it. However, there's a problem. We don't have any ether. So before we can send any transactions, we need to have some ether to pay the gas fees. So we'll reject it for now and let's go back. Now, because I'm using Ganache, it's just for testing purposes. I can go up to when I started Ganache and I can find my private key. So this private key, I can add it to MetaMask. Go here, import account, paste and import. Now I magically have 99 ether. That's because when I start Ganache, it will automatically generate 10, I think it's 10 accounts, and each of them will have 100 ether by default. This is not exactly 100 because I paid some gas fee to actually deploy the contract, and now this is what's left. Because this was a new account, let's link it to the web app, and yes, that's sorted. If I go to something like mainnet, I will actually need to buy real ether, which I won't be doing for this tutorial, but let's just go to localhost and try the transaction again. And yes, no errors. And let me just open up the console here. And these are the logs from Ganache. Let's just keep an eye on them. And if I confirm, and we have the transaction hash, this is all the transaction details. Events, there was a transfer event which is emitted by the ERC721 contract I used. Transfer, raw, return values. You also see the token ID to, from, everything. So also if we go back to VS Code, we can see here that there was a transaction. And yeah, we have token minted successfully. And that was pretty much it. We just used Web3 to transact with a real smart contract. Now let's move on to scenario number 2. In this scenario, you won't actually be deploying the contracts yourself. You might want to interact with a contract that's already been deployed by maybe someone else. So let's see how we would go on about that. Okay, so for this, the contract that we'll be using is the DAI stablecoin contract deployed to a test network. I already have the address of this contract and I just want to see my balance through my own app. And I know that the DAI contract is actually a ERC20 contract, which I can see on Etherscan. And yeah, so it's an ERC20 contract. And let's do some more stuff. So here, NFT contract, and let's also have an ERC20 contract. Here, ERC20 contract. Okay, so now we run into somewhat of an issue. We don't really have the build file for this because it's not our contract. But that's perfectly fine. I mean, we don't necessarily need it. We just need the ABI that's contained in this JSON file. So the ABI is just a description of the functions of that contract, but we don't need all of it. For example, if we look at the ABI for this, it's actually quite big. I mean, that's a lot of information. The thing is, we don't need all the functions. We just needed this one function, mint. And just like that, for the ERC20 contract, we only need the balance of function. That's the function that we will be calling. So let's const ERC20 ABI, and this will be an array, and then inside there will be an object. Okay, so now I don't really know the actual ABI, so I'm just going to go on Google, type ERC20 API. If it uses a popular standard like ERC20, it should be quite simple just finding it online. So we can just click on this one and there we go. That's the whole API. That's everything we need. Actually, it's more than what we need. So we just need the balance of function. I'm going to copy this and paste it here. And there we go. We have the API. Here we do ERC20 API, and now all we need is the address, which I already have because I found it online. So I'm just going to paste that here, and now we have the contract for the ERC20 and we can interact with it. Export const get own balance, and here we go, return ERC20 contract. Again, methods balance off. By the way, you can go here into the API and you can see the actual arguments that it takes in. So we have the address, type address, and that's the only one that it takes. And here's the output, which is an integer, unsigned integer, and it's the actual balance. So methods balance off, and we pass in the selected account again. That's the account that we want the balance of, and then dot call. Now, okay, let's try this out. Go back to our get app component, import the get own balance, and fetch balance. Now let's comment all this out related to minting, because that's going to cause some problems, as we're going to be using two different networks. If you add all the error handling and stuff, then it's fine. I mean, then you can use as many networks as you want. But for the purpose of this tutorial, we won't be adding any error handling and stuff. So let's just comment out this. Okay, so that should be good enough. So we go here, add balance, set balance, and we'll initially set this to 0. Okay, so let's go here. Let's have your balance is balance, and then down here we'll have a button that says refresh balance, and on click we will go ahead and fetch the balance, and here we'll have get own balance that we imported from Web3 client. And because again, this is a promise, just like before, all calls and transactions are asynchronous, so we will use then get the balance and set balance, and also add a catch function. Okay, so let's save this and go to the web app. Now if we refresh balance, and we get this error, cannot read properties of undefined. Oh yeah, of course. So just like we did before, for this transaction, we need to actually initialize the Web3 instance and set up the contracts properly. So let's try again. Okay, so now the problem is it does work. I'll get to why that's so long just in a bit. But the first time we get an error, and that's because here we set up everything, but in the background Web3 is still trying to connect to the provider and set up the contract. And to fix that problem, what we can do is just keep this, because this will await until the network until we have the network ID. And if we test it now again, refresh, core balance, and there we go, that's fixed. Now, why do we have such a long number? If we look here in MetaMask, the actual amount should be 82, but here we have something that starts with 82 but then has a long list of numbers. But that's just how most ERC20 contracts work. Not all of them, just most. It's just a convention. They have like something like 18 decimal places. And to sort of fix that, what we can do is here in the call, we can add then get the balance here. And then let's use Web3 again to convert from I think that's how you pronounce it, balance to the more standard unit. So let's save this and check it out. Actually, there's an error. Web3 is not defined. We're using this over here, there's import. So that's capital. So that should be capital W. Save. Let's check it out. So refresh balance, and there we go, 82.0233. Now we have that decimal place.
So yes, okay, so that's pretty much it. We've learned quite a bit, I think. We've learned how to make calls to contracts, but also how to send transactions, how we can use contracts that we deploy ourselves, but also the ones that have already been deployed. You may have the API or you may not have the API. We also explored how you can connect with MetaMask and what it does and all that stuff. Yeah, you should be able to. So just go and raise some funding.